This reference design is for making a computer vision product. It includes everything from schematics to bill of materials and firmware to behavior control.
Rollout. We share hardware reference designs for robotics so you can make your own hardware.
Hi there, welcome to Rollout. I'm Jeremy and today we're rolling out the E09 EZB camera. The EZB camera allows you to do camera tracking with colors, multicolors, faces, objects, custom HAR, which is elements of faces, QR codes, glyphs, and motion. It can do object training and recognition. You can also take advantage of cognitive services, which can pick up emotions, faces, and objects. It can also do augmented reality and variable overlays on the video feed. The camera can do video and snapshot capture, and it's all in a small form factor. Okay, let's hook up the camera to EasyBuilder. First, we'll need an EasyBuilder compatible board. In this case, it's the EZB IoTiny. Flip that around there. I'm going to use a set of helping hands to help me stabilize the camera. We'll plug it into that camera port there. We'll connect to the IoTiny with Wi-Fi. We'll connect to it, an EasyBuilder. Next, let's add a camera control in the camera section, camera device. Then we'll have to hit start. Okay, while we're here, let's do some object training. We go under Object, Train New Object. We'll have to enter the object's name, which is runts. I have a little runts container here. And we'll select a little bounding box, make sure that fits in it pretty good. And then we'll go Learn Selected Area. Now let's move it around a little bit so it kind of trains the different positions that the object can be in. And that's hit done. So in order for the camera to pick up the object, we're going to have to select Object under the tracking section. So you can get picked up here. So we move it around. And if we had servos, this can do pan and tilt tracking if we needed it to. Okay, let's move on to multicolor tracking. So deselect object, select multicolor. We'll go up to multicolor and we'll edit. And let's use this little pin, this little bowling pin. We'll dial in on the color that it is. There we go. It's nice and bright there. It's picking up some of my shirt, so let's try to get that out of there. Okay, I think that's good. Then we can also change the saturation. Let's leave that max. Let's change the minimum. There we go. That looks great. We can also change the luminance a little bit, but I think that looks great right now. So we'll save that, and since we already enabled the multicolor tracking, it's tracking it. There we go. Lastly, let's do some glyph recognition and tracking. So turn off multicolor, and with glyph, we don't have to change any settings. These are actually saved in an EasyBuilder. There we go. Just instantly picks it up. Doesn't matter which orientation I have it, it'll get picked up. Matters if you turn it too far that the camera can't see it, then it doesn't get picked up, but make sure it's nice and flat and it'll get tracked real easily. Let's move over to the schematic so we can see the internals of the camera. So here's the schematic for the EZB camera. We have two regulators here, 1.3 volts and 2.8 volts. That's what the camera needs. This is the breakout pin header that goes from the PCB to the camera itself, which is on a ribbon cable. We have the camera port that goes to the EZB. There's a little programming port here, but that's not populated. We have an RGB status LED, tell us if the camera is communicating or not. And this is the main processing chip, and that takes the image and converts it to UART to go to the EZB. Next, let's look at the E09 bill of materials. Starting out, we have our PCB at the top there. There's our processing chip, the STM32 407. Also, the next is the camera. We have the crystal oscillator, 25 megahertz. There's our regulators. And our RGB LED, some resistors, some caps. That's the header for the camera, which the ribbon fits into. And there's the JST connector that goes to the EZB. And there's also a heatsink that goes on the back of the ARM processor chip. One thing to note is that the ARM chip requires custom firmware, but we provide that for you on the GitHub page for the camera. That was the E09 EZB camera reference design. Find the links for the Synthiam behavior controls and the GitHub reference design files in the description box below. And don't forget to subscribe so you can get notifications for the new rollout videos. Over and out.
Thank you for watching Rollout. For more information, visit www.synthiam.com.